The IC Pumpstation control unit eliminates cavitation, or doesn't allow it to happen more accurately right there. This is a conventional variable speed control, where that once you turn it on, it'll speed up or slow down the pump motor we have right here to maintain 25 psi is what we have there. So we'll turn it on, and you can see it ramp up now. And it speeds up or slows down the pump motor using a variable frequency drive to maintain 25 psi, which is the target pressure that we've got set there. Okay. But the problem with this setup, as long as everything's working fine, it works fine, except that if you get a leak in the suction, a leak in the discharge, the plug filter, the pump will simply rev up and cavitate and cause a lot of problems, possibly pump damage, and it's also very inefficient power-wise. So we can demonstrate that here by shutting it down, the suction down, and you'll hear the pump start revving up, and you can hear the cavitation really going on in the pump. So this gets very violent and the pressure goes down, obviously, and the pump counters that by just simply speeding it up, and it goes full blast in an attempt to, because it's trying to maintain that 25 psi, and there's not enough water flow in there to do that, and so basically just keeps on going until something breaks, and that's never a good situation. So we've introduced the bubbles, and now the pump is cavitating, and then there's very little pressure being maintained, but all it does is just rev up in an attempt to maintain the target pressure. This is very inefficient power-wise, because all your power is going to beat up the pump instead of moving water like it's supposed to. So, it looks like it's recovered, and then there's some extra noise, because there's some bubbles still there.
Right. Okay, so now we're going to show in the cavitation mode?
Yes, anti-cavitation.
Anti-cavitation mode.
Okay, we'll just select the model here, and this goes from model 30 is the anti-cavitation mode. Turn it off, it resets everything. Now this has been pre-programmed, so it's already learned the parameters for this particular pump. So now if you notice the difference in when we cut off or shut off the intake water, and rather than revving up, it'll slow down, and you can see the light flashing, which means that the information it has stored externally is matching up with the information it's getting currently, and so it slows down, it flashes this light and slows down the pump, and it can slow it down way down, depending on right here. So we're going, rather than speed up and beat up the pump. And there's a variance in this also too, so that it doesn't have to be exact, but you can adjust the variance so you don't get nuisance tripping, but you do get the proper action. And then, assuming there isn't too much water or air introduced into the system, it can recover and go back to its full pressure in time, the proper delays.
But it'll keep on running as long as in the cavitation. It'll slow it down to meet the demand, the flow.
And if it gets too bad and the safeties are enabled, right now the safeties are disabled, and how you get that is the safety, low pressure safe is 0, which means it's disabled, so it won't go in. But if you want to shut off and stay off in the safety mode, simply put a figure on here, number whatever, and if it goes below that pressure for 30 seconds continuously, then it'll shut off and stay off, and it has to be reset. So that may be better in some applications.
So yeah, like let's do with this where we really insert a lot of air. Sure. We would want to have that, right?
With the safety, you mean?
Yeah.
Sure. Yeah, we can do that. Let's put it. Safety would be something like that. As long as it stays under that figure for 30 seconds continuously. And then you can do it either way, cut off the suction or the air, but the pressure you can maintain above that point for 30 seconds or more continuously, and it'll shut down on safety and stop, and it'll have to be manually reset, and that may be better for many applications. We also offer options when it does go into safety, it closes a relay and shuts everything off, it activates the relay so that you can turn on a light or a siren or a horn or something like that, and alert people that the pump is shut down. 30 seconds, seems like it's a there it goes.
There it
Shuts
is.
off on
Okay.
safety.
Okay.
And then to reset it, all you have to do is stop, turn it off, turn it back on again, and it'll start for an attempt to try to start it up again.
Right. See the bubbles coming through.
Yep. Yeah, it's definitely got some issues.
But we can hear this not ramping up.
Yeah, it's very
down.
slow. And that's adjustable too. I mean, you can. There's a variant. There it goes
Right,
into
there it
safety
goes
mode,
again.
just like it's supposed to.
Okay.
There's also a variant, so you can keep it from nuisance tripping, but you do want it to react properly and trip at the right times, but you don't want it tripping just for any little issue sort of thing, and that's adjustable internally.
But can we show it with low pressure safety off and show how it will recover?
Oh, sure, yeah.
Okay.
All we have to do is turn it back on, just run the safety
Down to zero.
Down to zero, and then it just ignores it. It's like it doesn't exist.
So
we
now,
got don't turn. Oh, we already got air in there.
Oh, we already have air. So here's how it would recover.
Still trying to recover from that.
Right, but eventually it would recover.
It would, yeah.
So right now it's showing that it's below the 25 target pressure.
Right.
At 14.
We're still getting some bubbles.
So it's going to
eventually it'll work
its way out slowly.
Right, and most leaks you get are not immediate or full leaks, they're small leaks. So, and what the IC Pumpstation will do is to simply slow down and maintain that to whatever flow rate that it can handle. And or you can put the safeties in and shut it off. Either way it works just fine.
And it will also detect can be set up to detect a discharge.
Oh, absolutely, yeah.
So up on the discharge.
Right, if you plug it, or if you open that valve and add a load to it right there, say like there's a pipe break or something right there, it will slow down too. And we can make it learn the higher flow rate too, but most of the time pumps are set up for specific flow rates.
Specific that matches the pump itself.
Pump characteristics, actually.
Right.
And then it stores that in memory and then constantly references that. And when this top light is off, that means that the internal stored information is matching the information that it learns.
Right. So if there's a blockage on the discharge, it will also detect it.
Absolutely. We'll slow this down. See how the light goes on right there? And it'll slow it down also. As well as because it doesn't, the flow rate and the information that it's been taught, so to speak, doesn't match the information it's getting from the pump. What we do is just simply reduce the flow rate to whatever the filter will allow through it safely as you've taught it, so to speak.
And then you also have a function where you can also do a backflush on the filter.
Absolutely, yeah, an option, yes,
So that it'll automatically do it, not based on time.
No,
absolutely
based
organic.
Plug, yeah, right.
It's truly plug, not because it's 30 minutes or 30 days or whatever. It's going to backflush it because it feels.
Oh, absolutely.
It senses a difference.
Well, there will be a time function, but it'll trigger the backflush based on the blockage present.
Right. So there we went back to 25.
Right. And then we can add another load over here. We can add the sprinkler load here. It's another volume load, and it has not learned that. There we go. Notice the light is turning on the top. The pressure has dropped right there because it has a load that it's not familiar with. It's not, so, which is fine right there. It's just pumping whatever it's capable of pumping safely. Another pump will just ramp up and
So if we were to put that second load on there, the second sprinkler on there in non-cavitation, anti-cavitation mode,
they just go full blast.
It would go full blast.
Right.
It wastes a lot of electricity.
Absolutely, yeah.
That's the whole point. That this
Certainly.
Well, so finally, VFDs typically are not really out of the box, truly energy savers, because there's a lot of inversion going on. There's a lot of change in frequency.
Real world conditions that they're not up to.
Right, but when you do cavitation, anti-cavitation mode, we will save you electricity.
Oh, absolutely, because it doesn't allow it to get inefficient, as you can see.